abbiamo chiuso i saluti e ora avviamoci veramente al convegno. Abbiamo come presentazione principale invitato una persona che ha dedicato la sua vita alla didattica ad altissimo livello. Dal 1967 si occupa di questi aspetti, diciamo, da una posizione rilevante. È il dottor Sorel Reisman. Vi leggo il suo biglietto da visita perché è importante leggerlo, che è Melbourne Managing Director del California State University Chancellor Office, è Editor in Chief dell'IEEE Electronic Learning Products, basta IEEE per dire di che stiamo parlando, Board Member Open Courseware Consortium, Professor ISCSU Fullerton, Presidente Emeritus IEEE Computer Society. Essere Presidente Emeritus della IEEE Computer Society non è una cosa banale. Bene, abbiamo il piacere di avere con noi il professore Reisman che ci presenterà un suo lavoro su Instructional Technology Past, Present and Future. Guardate bene, sono le tematiche del nostro convegno di Didamatica, quelle che ci seguiranno in questi giorni. Prego.
Good morning, everybody. It's a great pleasure for me to be here this morning and have the opportunity to share with you some of my thoughts about the past, the present, and perhaps the future of instructional technology, in particular about e-learning. I'd like to thank my hosts and the conference organizers for inviting me here, the Italian Computer Society, which I just learned is a sister society of the IEEE Computer Society, and all my friends, I have many, in Milano and in Torino. And it's a great pleasure for me to be here at the University of Naples. So I'd like to thank the university here for hosting the conference and giving me the opportunity to return to Naples after, I'm embarrassed to say, almost 50 years. So I will begin this morning by giving you my personal views of instructional technology as it exists today at the present time. I'm going to talk a little bit about how we got here today, and then I'm going to talk about what I think is a possible future scenario of instructional technology, and I'm going to talk about employee training. So e-learning, instructional technology at the end, and employee training. After decades of relative obscurity, except maybe in higher education, learning research laboratories, and in some Fortune 500 training centers, e-learning and distance learning didn't get very many news headlines. So even though the whole notion of machine teaching and learning has been around for more than 100 years. Could you ask these guys to keep their voices down, please? Yeah. Even though the technology, machine learning, has been around for more than 100 years, according to Wikipedia, 2012 was declared the year of MOOC. And e-learning was suddenly in the public eye. This relatively recent event took place even though the term MOOC has been around since 2008. So what happened in 2012 to cause this? I think it happened because a few very high-profile professors at some top universities made news headlines with incredible reports of teaching tens of thousands of students at a time online. Nobody asked if the students were learning or not. People would ask that question later. But because of the instructors' high profiles, and because of those incredible reports in the newspapers about MOOCs, we saw the creation of several well-financed startup e-learning companies. And I believe that was also mainly because they were also associated in one way or another with top universities. By the way, as a digression, I just read last night that Google is now going into the learning management system business, the LMS business. So many companies think there's a big opportunity to capitalize on e-learning, and this has never happened before. So here we are today, 2 years later, trying to make sense of all of this that's going on and what to do about e-learning and online learning now that we are getting some realistic reports about the success and failures of MOOCs. Clearly, it's impossible to talk about the future instructional technology without having a closer look at what I call MOOC version 1.0. But I ask the question, are MOOCs really the future of education? Currently, aside from the popular press, and this will bother some of you, most supporters of MOOCs are politicians and university administrators who believe that MOOCs are the solution to the rising costs of education. University administrators. And then there are venture capitalists and companies like Google, for example, but others that I showed you before, who dream about getting some of that $18 billion that's spent every year in the United States on e-learning in higher education. But many of us in the room who might become responsible for actually developing and teaching with MOOCs may not be so enthusiastic. And sometimes we wonder whether or not MOOCs are just another instructional technology fad. I didn't understand the Italian introduction for myself, but I have been around in instructional technology. It's been my career for decades and decades and decades. And I have seen many instructional technology, educational technologies that seem to have an incredible future come and go. Is this yet another one? But in any case, regarding MOOCs, it's pretty clear that everyone is a long way from declaring victory about what they think about MOOCs. As an instructor and as an instructional technologist, I think it's right to be cautious and even critical of the current version of MOOCs. And that's because I believe they are built on what I consider to be a faulty instructional technology construct. If you think about it, a MOOC is really just an online course offered to a lot more people than usual on a scalable version of a conventional learning management system, or LMS. And if you think about the construct or architecture of LMSs, you soon realize that these platforms have very little to do with learning, but mostly to do with teaching. They really should be called teaching management systems, because what they do is they allow an instructor to collect, stage, and present content to students. There's really very little functionality in today's LMSs to allow an instructor, or even the LMS itself, to know whether or not the student is learning. Another characteristic of these LMS-based e-learning courses is they are not available usually on demand. They are scheduled events, usually in sync with the semester schedule of the institution that offers the course. That is, they're not self-paced. They are scheduled and controlled and monitored by an instructor or the institution throughout a semester. And they're designed to allow students to participate in the course only at scheduled times over the duration of the course. That's not true for all MOOCs or all e-learning courses, but currently most of them. MOOCs are the same. In fact, they're the same course that we offer online for credit to registered college students. The main difference is that a MOOC course is advertised and it's open for a larger audience than the usual pre-selected registered college student. Often, anyone can register for a MOOC. The only prerequisite is that the student who is registering has to have some kind of interest or curiosity in the subject of the course. While some of the students might register to get academic credit, most MOOC registrants usually don't. From our experience in teaching conventional online courses at various levels of education, we know that students must be self-motivated to complete a college-level online course. Students who aren't registered, who are just auditing a course because they're curious about the subject matter, usually drop out. And those who aren't mature and self-disciplined are usually unsuccessful. Consider, for example, that most pre-college students do more poorly in online courses than do more mature seniors or graduate students. So it's no surprise that when we open an online course to a worldwide student body, almost all of whom who register because the course sounds interesting, that we see reports like this, where typically, where people register for interest's sake, we see dropout rates of greater than 90% and success rates in exams of under 3%. As I described before, an LMS used to deliver a MOOC is usually identical to a standard LMS. The main difference, aside from the scalability of the LMS, is that the MOOC LMS has to support improved social networking tools. These tools go beyond the ordinary threaded discussion in a typical online class. MOOC social networking tools are more extensive than threaded discussion because they allow students to address problems working together. And that's necessary because it's impossible for a class of hundreds or tens of thousands to be easily supported by just one or two instructors. To better understand how we got to where we are today, let's see where all of this started. Let's look back at the almost 100-year history of instructional technology that started in 1924 with the testing machine invented by someone named Sidney Cressy. It's amazing to note that today's LMS-managed model of online instruction that MOOCs are based on, and even the hot new term adaptive learning that I'll talk about in a few minutes, are derived from instructional models used in teaching machines that were invented almost 75 years ago. In the late 40s and early 1950s, so-called self-paced instruction was delivered via specially designed textbooks called programmed instruction, or PI manuals. And they were invented by two competing educational psychologists, B.F. Skinner and Norman Crowder. About 10 years later, these programmed instruction manuals were deployed on electromechanical teaching machines. But their usefulness was very limited because of the limitations of the technologies. In the late 50s and early 60s, when digital computers were commercialized, customized computer-assisted instruction, or CAI systems, replaced those teaching machines. These new CAI systems provided a much broader spectrum of content delivery and improved learning possibilities than was available from the electronic teaching machines, electromechanical teaching machines. CAI instructional designers, computer-assisted instruction, didn't have to limit their presentation to just simple text. They could now use multimedia delivered on colored screens. Complex software-driven algorithms could now process students' keyed entry responses to questions presented on CRT terminal keyboards. And of course, the new CAI system software could provide more powerful decision-making under control of, and along limitless branches based on students' responses to questions presented by the CAI system. However, while the technology had greatly improved, the body of theoretical knowledge on how best to use it was not very improved. It was very thin. In the 1960s and the 1970s, the psychologists Lee J. Cronbach and Richard Snow proposed a learning construct called aptitude by treatment interactions, or ATIs. They suggested that students with different or varying degrees of aptitude can learn better if instruction can be adapted and optimized for their individual aptitudes. This might mean that for any particular learning task, if learner A learns better by reading text than learner B, who learns better by listening to audio, it would be best to provide textual learning materials to learner A and audio to learner B. The real and practical challenge, however, was how to identify or discover aptitudes that might make a difference in learning, and how to use those for each different learner, each different student. And even if we could, what would we do about it when we know those things? What kind of instruction do we actually deliver? And finally, what kind of content needs to be designed to present to a student once the student has somehow responded to a question? There's no doubt that these are very difficult questions. And while matters like these have been researched and debated for years, the world of e-learning has not stood still, and it hasn't waited for answers to these questions. Instead, the e-learning industry has taken the easier path of standardizing on group lecture-style e-teaching, including the MOOC model. Unfortunately, most current e-learning scenarios have little concern for anything concerning matters related to students' individual differences, or ATIs. So here we are today with an e-learning industry that's taken the path of least resistance and really doesn't care that much about learning, but cares a lot more about teaching. And it's an industry that believes that the best return on investment is to teach lots and lots of students in large groups. Not so different from the lecture-based teaching with which we are all so familiar, like this, and which is so much criticized by professors and students alike. But in the same way that digital computers revolutionized machine-based learning, there are new digital computer technologies that have the potential to revolutionize e-teaching so that it can really become e-learning, and it can do a much better job of online instruction than we're doing today. As I mentioned earlier, the hot new term in instructional technology is adaptive learning. Let's see how Wikipedia defines adaptive learning. In an adaptive e-learning situation, the computer adapts the material it presents to a student based on the student's most current response. You can see from this definition that adaptive learning is just the computerization of some of the earlier programmed instruction manuals that I mentioned a few minutes ago. This definition is okay for today, but if we look to the future, where computer-based systems have access to lots and lots of data from many, many different sources, the definition can be expanded to include the fact that real adaptive learning must also be based on other criteria and data that can help to optimize the content next presented to a student. It's the second, it's my addition to the definition. It's the second part of this definition that I've added that I think is key for bringing about a revolution, a new revolution in e-learning. Using adaptive learning methodologies, a true learning management system should be like a private tutor. It should know a lot about the student. At every moment during the instruction, it should present the student with different content or use different instructional modalities such as text or audio or video based on the knowledge of the student and what's going on right then and there. Fundamental to all of this, as I said, is the availability of lots and lots of processable data to enable the LMS of the future to make instantaneous decisions about what and how to teach next in real time. In order to do this, an adaptive system must take advantage of new technologies and on the fly use interoperable cloud computing-based big data to draw on data science-based methodologies using emerging semantic web and other standards to differentially provide instruction to individual students and to do all of this in real time. That's a very long sentence with a lot of implications for every one of the bullets on here. Let's have a quick look at these technologies and see how all of this might happen. A key technology that an adaptive LMS of the future will depend on is cloud computing. For true adaptive e-learning to take place, large volumes of data must come from many, many different sources. Interoperable clouds have the potential to enable the integrated access of sharing from those many sources, all available when needed from one virtual data mine in the sky. The ability to analyze those huge amounts of data depends on the technology called big data. In instructional settings, big data stores would contain data not only about a specific student in a specific e-learning situation, but also about thousands or even millions of other students, containing many different kinds of data, personal, geographic, demographic, etc. Consequently, the LMS of the future should be able to not only diagnose the state of a particular student in a particular online course at a particular moment in time, but must be able to present different instructional content with a high degree of likelihood that it will be effective for that student also at that moment in time. And interestingly, the kind of data stores that the LMS might use to decide what to do next don't even have to be based on traditional metrics, such as a student's math or verbal aptitudes. They could be taken from a student's Facebook or Twitter account, which has very serious other implications with regard to privacy, security, ethics, etc. But of course, I don't have time to go into any of that today. One of the aspects of all this data access and processing is standards. Without standards, for example, related to cloud technologies, it'll be impossible for the LMS of the future to access all those data mines that reside in multiple cloud-based databases. An important activity currently underway in IEEE that can facilitate cloud interoperability is work that was started by the IEEE Cloud Computing Initiative. And that work is now being done by the IEEE Standards Association P2301 and P2302 working groups. If you don't know about standards, they come out of working groups such as these two that you can find at the IEEE.org website. But going back to our LMSs, etc. Another important element to all of this is our ability for our adaptive LMS to somehow relate cloud-based data to other data in order to make the good decisions about what to do next in a teaching situation. It's through work such as the W3C's semantic web activity that those adaptive LMSs will be able to know when it finds a student's Facebook data, whether or not the data can be used to access the student's frame of mind when the student says whatever when he is asked, is New Zealand north or south of the equator? If you want to learn more about the relationship of the semantic web to education, I'd like to draw your attention to the IEEE Computer Society website called Computing Now. The April 2014 version of this website was edited some very good friends of mine, and probably some of yours. I put a red circle around here. It's a great source of up-to-date articles on this topic, and the semantic web in education. And all these articles have been published in IEEE magazines and journals that are available in IEEE's and the Computer Society's digital libraries. All right, I'm going to talk now about a different kind of standard. Let's imagine for a moment that our hypothetical adaptive LMS of the future can diagnose various states of a student who's in the middle of a lesson. The student has just been presented some content, asked a question, and the student has somehow answered. The LMS has to decide what to do next, what to present, how best to present it. So let's pretend that the LMS has a huge library of reusable learning materials that it can choose from. Which one would be the most appropriate to select and present at this current moment in time? Today, in this kind of situation, there are very many reusable learning object or content libraries available to find learning objects to present. Those libraries are used today by e-learning course designers to select materials to use in their courses. Because we don't yet have this hypothetical LMS of the future, the decision regarding which content or learning object to present next is not made by an LMS in real time. In fact, as we've seen, most of today's LMS instruction isn't self-paced, it's linear, and it doesn't depend on student responses. The content or learning material presentation and its sequencing are predetermined and preloaded into the LMS by an instructor. But in any case, while it's relatively straightforward today to pre-build or pre-select such content from libraries of learning objects, it's a real guess when we choose those things whether or not those things that we're going to present are really going to work, if the student's really going to learn. Over the last few years, with the increased attention to online learning, a number of organizations have focused their interest on developing learning object metadata standards to describe content available for e-learning, and also on using such standards to make online materials, sometimes called open education resources, about which I can speak forever also, make these things available to the widest audience of instructors. Well, the learning object metadata today can somehow be attached to an OER. Those learning objects can be more readily discovered by instructors who are searching for materials to integrate into their courses. And as a small digression, I am the managing director of a digital library. It's an internationally used library, a digital library of learning objects. It's called Merlot, and I invite you to visit the website www.merlot, MERLOT.org. It's a digital library of about 45,000 learning objects that are classified by academic discipline, and the language that you would use when you go there is any language that you want, including Italian. So the metadata that we use to describe online learning objects are essential, would be essential for our LMS of the future to be able to identify cloud resident effective learning objects to use in real time, such as those in my own digital library. One of the problems with today's learning object metadata standards is that none of them includes metadata that describes how effective, in terms of learning outcomes, a learning object is. It just describes the nature of the learning object. Not does it work, doesn't it work, does it work under this circumstance, does it work under that circumstance. So while you can search for, like in my library, and find reusable learning objects that seem to be wonderful, you don't know until you use the learning object if it works or not. Does the student learn it? Recently, committees such as the IMS Learning Consortium, perhaps the preeminent among all such standards groups, have been addressing this deficiency. This kind of work is very preliminary, but it gives us some hope that eventually OER metadata might provide us with clues about the quality of OER discovered on the World Wide Web. Okay, so what's next? Where do we go from here? What's the future? When I started to talk, I mentioned that e-learning over the decades has been used by Fortune 500. These companies have always seen e-learning as a practical way to train and educate their employees. I think that it's likely that future developments in LMS evolution are likely to be driven by companies who can continue to seek effective ways to provide employee training. So while MOOCs have attracted a lot of attention, most MOOC activity is focused on university or continuing education programs. And in some ways, MOOCs are unsuitable for industry needs. The IEEE and many others have developed libraries of courses that are made available to universities and to businesses in order to provide training for members of their professional societies. This is the IEEE Learning Library for which I'm responsible. There are companies such as this one, Skillsoft, that the IEEE ones have to do mostly with electrical engineering subjects. Skillsoft provides libraries of more general courses that have to do with maybe introductory IT kinds of things, basic programming, things like Python, etc. And the IEEE Computer Society also offers these Skillsoft courses and also provides courses, for example, in software engineering to its members free of charge. In fact, I pay for the membership of the people that work for me to the Computer Society so that they will take these courses, and those courses are part of their annual review. But of the future, what do we think about the future? One of the things that has been discussed for years is the subject of just-in-time online education. MOOCs, the courses that we offer, that IEEE offers, those things don't deal with the immediate needs of somebody who has a problem, who needs immediate education and training in order to solve the problem. So we have this concept that has been discussed for a long time called just-in-time online education. So in this paradigm, it's a paradigm change. You notice the motto of this conference. Typically, we have university or employer-supplied learning. But when an employee needs to solve a problem, and if we had e-learning systems or LMSs of the future that can address the problem for the employee, then we have a change. We have employee demand-driven e-learning. Key, I think, can be key to this just-in-time learning is the notion of wearable computing. And here's how I see this. In the future, in fact, not so much in the future, we have this concept of the Internet of Things. Every single device or entity, this is from Intel, a concept from Intel, every entity on the network of the Internet of Things exists in a state. And in the Internet of Things, there are sensors throughout the Internet and throughout the network that detect the state of a thing on the Internet of Things and then sends data back to alter the state of the device on the network in the Internet of Things. Consider this. A learner can be just another thing in the Internet of Things. The learner, or the employee, or the student, is in a certain state, has a need for a certain kind of a problem to be addressed. Somehow sensors in the wearable computing close of the learner sends data back to our LMS in the cloud. Our LMS in the cloud detects, knows, goes into the data stores in the cloud, uses data mining, brings together all these data in order to send back to the learner, the student, the trainee, the kinds of information that this person wants. This is a more extensive drawing of wearable computing. Of course, it's just a drawing. But these kinds of sensors that can detect the state of a learner, here is a product that's being shipped this month. It's called Vigo. You wear it here, it looks at your eye movements, and it can tell when you're, from the blinking of your eye, whether you're paying attention or you're falling asleep. This is just one kind of sensor that can be used to send data back to our LMS in the future to detect the mood of the learner. There are all kinds of different things. Many of these things we know about, all kinds of sensor-based devices that can send biometric data that would include the learning, what the student knows and doesn't know. It's a different synergy of data being processed by our data mining algorithms accessing our interoperable clouds. There's a very interesting set of articles in IEEE Computer Magazine, and this is called Aware Computing. It's in the current issue. I just read about it on the airplane. I want to draw your attention to it in the IEEE Computer Magazine that talks more about what I'm talking about. So even though I thought about it before them, now there's some articles that you can read more about this. So in this scenario, what we have is just-in-time, sensor-based, automatic, Google-like search to provide customized information to a just-in-time learner. So, whether you believe that the future is how I portrayed it or not, we can talk about it in the questions and the answers and so forth. But in any case, whatever the future is, we are living in the present. And as we were talking about last night, we have to deal with the issues of the present. And MOOCs are a phenomenon of the present. I personally think they are not a phenomenon of the future. I think that when all of these technologies that I've sort of alluded to begin to come together, as frightening as it could be, I believe that the kinds of just-in-time, automated, Google-like searches that I've described are really the future of what today we call e-learning, what we call computer-assisted instruction 40 years ago, what we called teaching machine-based learning 75 years ago. My only Italian.